Hello there! This video provides a brief overview of the scientific method. So really, we're going to look at how scientific discoveries are made and revised and made again. It's a cyclical process. So remember that our understanding of the world is always improving. Scientific breakthroughs should not be seen as a sign that experts were wrong in the past, but a sign that the scientific method is doing its job to refine our understanding of ourselves and our world. So in this video, I will cover the scientific method and how that translates into research and the research manuscripts that we see in academic journal articles. Then I'll cover the hourglass of research, how we start broad, get narrow, and then get broad again through inductive and deductive reasoning. Then looking at how the scientific method differs from pseudoscience and some things to look out for to know that you're looking at pseudoscience and not legit scientific method-based science. And then just a brief overview of where you can obtain these research findings that are acquired through the scientific method. So the scientific method really creates a research structure that helps us create research that's quantifiable, so it can be measured with numbers, verifiable, so it includes data that supports those claims, is able to be replicated, so with clear research methods that can be recreated, and defensible with that supporting data and also drawing from past research and theory. So I'm going to break down the scientific method for you in terms of kind of the steps of the scientific method, what that really is in simple language or plain English, and then how that translates into the research manuscripts that you see in academic journals. So we start off by kind of figuring out what we're interested in, right? Maybe we make an observation and we're curious about that observation and we want to know more. So we could develop a research idea and then start to identify the variables of interest there. Then that really translates into a literature review. So before you can develop your hypotheses, you need to read what past research has found and figure out what you think is going to happen in your research. And this process is important as well when you're doing your own actual research, because you want to join the conversation being held by other researchers. And you don't want to necessarily do research that's already been done before. You want to make adjustments to that. So you read the research to justify your hypotheses and your predictions, but you also make some tweaks so that you can push the research forward and fill gaps in past research. So that literature review helps you develop your expectations. And then the background research on past research on the topic and your hypotheses both feed into the introduction section of a manuscript. Then to test your hypotheses, you have to operationalize, measure, right, and collect data. So a lot of the variables that we look at in psychological research aren't clearly numeric in nature. So you have to figure out ways to measure that with Likert scales or with other objective indicators that can be quantified. Then you can actually collect your data and do your research. And that feeds into the method. Now keep in mind that not all data has to be quantifiable, right, and quantitative. There's also qualitative research where you talk to people and you do interviews or you ask open-ended questions and then you figure out what's going on based on those responses. So remember, quantitative research is numeric and qualitative research is more open-ended, and you can like observe what's going on and talk to people, and it's more like a written version of data collection. The next part of the scientific method is to then analyze that collected data and interpret that data to test the hypothesis. So you'll do a statistical analysis. You'll see if there's differences between groups or relationships among the variables you are interested in. And then you'll go back and you'll say, okay, so what does this suggest about my expectations or the hypotheses that I generated based on past research? Then ideally, you'll report those findings out and you'll put those in the results section of a manuscript or even in a conference presentation if you're delivering this research in a conference and not in a manuscript or a journal article. Then the next step is to critically evaluate those results and then start the process all over again by refining your research. So when you read academic journal articles, you'll see that in the discussion section, they not only talk about the so what of their findings, right? So why do these findings matter? Overall, what does it mean? And how does it add to the body of pre-existing and past research? But you also talk about some of the limitations of the research, and future directions that should take place to further that research. So when you're jumping into the research literature, and if you're trying to develop your own study, it's a really good idea to go to the discussion and they tell you kind of, hey, this is the future direction. This is what the next project should do. And maybe you can jump in and contribute to that. So this is kind of the scientific method overall in general, how that feeds into research manuscripts, and how this process is really cyclical, right? You get an idea, you collect data, you figure out what's going on, you evaluate it, and then you refine your methods and you keep going back at it again. And other researchers can jump in and do it as well because, again, you included your method, so they have that recipe for how you did your research so that they can replicate it as well. So here you can see the hourglass of research, where we start broad, get narrow, and then get broad again. So when we're doing research, we usually start with a broad question or an observation about the population. Then we move on to doing a literature search to figure out, what do we think is going on? What's underlying that observation that we made, right? What's going on in the background? Figuring out what past research suggests, and then making an educated guess or an educated prediction about what you think you'll see in your specific sample that you're going to research based on what past research suggests about what's going on in the population. Then you get even more specific, and you have to figure out a way to measure the variables that you're interested in or operationalize those variables. And a lot of times in psychological research, the variables that we want to study are more qualitative in nature. They're not necessarily numeric, but we usually quantify those with Likert scales or other ways to measure things so that they're easy to analyze in a statistical data analysis. But remember that quantitative data is numeric, qualitative data is more open-ended in words, but sometimes we make qualitative variables numeric and quantify them to operationalize and measure them to do those analyses. Then we get even more narrow, right? We figure out what we're interested in. We identify what we think is going to happen, right? Make a educated guess, a hypothesis. Then we figure out how to measure that based on how it's measured in past research. Then we go on to collect data in our specific sample, who we're actually going to research. Then once we analyze that data to test our hypothesis, we can generate conclusions based on that about the population at large. Because remember, when we do research, we don't really care about the sample in of itself. We care about what that sample tells us about everybody in our population of interest. So this research process involves both deductive and inductive reasoning. So the deductive reasoning comes in at the beginning. You can see that here. So observations in specific samples from past research are used to justify a general hypothesis of how everyone or everything in the population functions or behaves. So for example, based on past research showing that college students with a greater sense of belonging tend to stay in school, I would deduce that students in my sample will have better graduation rates if they have structured opportunities to meaningfully connect with faculty and other students, right, to enhance their sense of belonging. So that's deductive reasoning. Then the research process also involves inductive reasoning, which is when you use results from a sample in a specific study to make predictions about specific events in the future. So if the results in my study suggest that students who are required to attend office hours twice a semester for each class and attend at least 2 student social events a semester have higher graduation rates, then I would promote implementing that requirement across all students in my institution and others. And remember, that's where you see in the discussion section of the manuscript when you look at those practical implications and applications of results. Like, okay, based on my sample, here's what everybody should do in the population at large. So remember, I mentioned the empirical strategy, right, for generating knowledge. And empirical strategy is involved in the scientific method because observations are really important. So the scientific method involves observations and measurements of things that are happening in real time. And the results will provide either, clear or support for the hypothesis or will clearly refute the hypothesis, right? So you have an idea that you want to test, you measure it, you test it, and then you can make decisions based on that. Scientific method also should be public. So you should have your observations available for evaluations by others, by publishing your research, by having peer reviewers, and again, by putting your methodology out there so that people can replicate your findings and see if they get similar results. Even with non-experimental methods, which is correlational research, you can really get a clear idea of what's going on if multiple studies are finding similar results. The scientific method is also objective, and this is the major advantage over doing your own research. You aren't basing your conclusions on what other people have found and what other news sources say. You're really focusing on what's justified by the hard data and the hard results. And so that's a really important piece of what makes the scientific method verifiable and a way to generate trusted conclusions. So as part of this lecture, I also want to equip you to be able to recognize the difference between science and pseudoscience. So unlike the scientific method, pseudoscience lends itself to discounting any finding that goes against past theory. So a lot of times in pseudoscience, results are ignored if they go against what was expected or what past research suggests. So pseudoscience also is usually stagnant or fixed because of this. So it's usually a set of unchanged beliefs or ideas instead of a constant refinement and update of theories and practices based on, remember, that cyclical process of the scientific method, right? You do research, you learn things, you make adjustments, you do more research. Also, pseudoscience usually involves subjective testimonials of just a few people. So instead of using the scientific method to find consistent results across many observations, pseudoscience relies on anecdotal evidence. Pseudoscience is also suspect if you're looking at something that has like a niche field of study or that something that's unconventional and not really grounded in past research and theory. So, for example, new medical treatments for depression should probably be based on neuroscience and psychiatric research, not co-occurring correlational events that correlate and have no experiments to back them up. So for instance, if there was, a situation where reported anxiety has increased over time, and we find that, a couple decades ago, the frequency of radio waves changed before people were so anxious, and then we try to say, oh, well, maybe the radio waves caused anxiety. That's pseudoscience, right? That's not even quite the rational method. You really have to have some strong evidence to back such things up, and again, relying on the scientific method, not just anecdotal evidence or things that correlated or co-occurred, or just the way that we feel about things. Although we do have access to scientific research, journal articles are often intimidating and not always free to access, especially if you're not affiliated with the university. So a lot of times we rely on news sources and reporters to give us the gist. But unfortunately, most news sources are not accountable to uphold the truth and are really incentivized to create outrage because it keeps people watching and clicking on their sources, right? So news editors are not always critical about the research they choose to report on and aren't always looking at peer-reviewed journals. Again, a lot of times the media picks up research that's from irreputable pay-to-publish journals. So keep in mind that you can get access to solid scientific method-based research and focusing on peer-reviewed academic journals. So if you're a student at an academic institution, you have institutional library access, and that is a great place to start when you're doing literature searches. If you're using Google Scholar, that's also a great source, and there's filters there to filter out peer-reviewed versus non-peer-reviewed. And if you're affiliated with an institution, you can use Google Scholar, and you can log in and add your library credentials, and you can get those journal articles for free through your institutional access. There's also some resources that have journal articles that are publicly available and free, like ResearchGate, PubMed, and the Directory of Open Access Journals. If you're doing a Google search and you're not logged into your institution, you may find journal articles out there that ask you to pay money to access them. And so that is a barrier to entry for a lot of people. And that, again, is why some people go to those magazines and those for-profit news sources and social media to get their information. But if you're in college, you're lucky. You have access to all of these great academic, quality peer-reviewed journals for free. So I hope that this lecture helped you see the difference between doing your own research for Google and doing empirical, scientific method-based research, and has helped give you some information to just be a wiser consumer of research as you move forward in your life.